Hello everyone and welcome to today's session on Kubernetes Service. Previously we had discussed about other Kubernetes objects like pods, replica set and deployment. We have discussed about how deployments create replica set and how replica set creates replicas of pods. And today the discussion point is something called service. Service. Now, in the previous session, I have discussed this. Suppose this is a deployment. Let's make it a bit bigger. Yeah. Okay. So this is a deployment, and we know inside deployment there should be what? There should be replica set. Clear? And we also know that inside a replica set there could be what? Replicas of pods. So let's create 3 replicas. Let us have 3 replicas. Okay, so let's call this one pod 1, pod 2 and pod 3. So this was the basic architecture that I have discussed previously. Let me just erase this service part. Yeah, so I have discussed that when you create deployment through YAML configuration file, it automatically creates replica set. And in that deployment YAML file, we mention something called replica X. So if you put it 3, it will create 3 pods. Okay, 3 copies of the same exact thing. Now today our discussion point is service, right? So why does service come here? Well, let's say this is service, yeah. And what basically service does is that, guess, it basically creates a connection. What service does? It basically creates a connection. And here, as you can see, what connection does it have? It has connection between pods, this one, and this one, as you can see here, here and here. So you can think service as a switch or hub, a common place for the copies or the replica sets. Okay, sorry, pods inside the replica set. Clear? So what is service? Service is basically a connection between what? Pods. So services are a Kubernetes object that create a connection between pods inside a replica set which is inside a deployment. Clear? Okay, so we know that service is a connection line or medium, whatever you want to call it, but the question is why? Why so that we need a service? Okay, why do we need the communication line between the pods? Let's get to this. Suppose this is our pod. Let's make 3 pods. This one and this one. Okay, there are 3 pods, identical pods in our node. Okay, let's again name them pod 1, pod 2 and pod 3. Now the question is why do we need service? Now, as I have discussed in the pod lecture, that each pod has its unique IP address. So let's give an address 1.2.1, 1.22.2 and 1.22.3. So these are the IP address of each individual pods. Okay. Now, when you create them, they are allocated these IP addresses, right? This is the address of these individual pods. If we just input or curl this IP address, we will get inside the pods. Okay. Now, the question is, does these pods know each other? Do they know each other? Well, when you create it for the first time inside the replica set, you know that these are my 3 pods. Okay, but as we know that pods are ephemeral, that is short-lived, anything can happen to them and they can get killed, cancel, die, whatever you want to say. And as we know, what replica set does is that it maintains a constant number of replicas inside your deployment or replica set. Okay, so if this pod dies, what will it do is that it will create another copy, but there's a huge but. What is that? The thing is that the newly created pod will have a new IP address. Suppose it will be 1.22.4. Okay, this is the new one. This is the rest of the IP addresses, but this is the new one. Now think like this. Let's say um, that these are front end pods, front end applications. Okay, and here you have a back end. It is another replica set, and this is another pod. Let's say it is a backend pod. So the front end needs to get connected with the backend, right? But it only knows these IP addresses 1.22, 1, 2 and 3. Okay, so this backend only knows these 3 addresses to connect to. But after one of the pods getting killed, a new pod arrived. Pod arrived in the scene with a new IP address. But it doesn't know it because it is not inside its list. So the backend would be able to connect to this and this, but it won't be able to connect to this one because it doesn't know it. Why this problem occurred? Because when the new pod got created, it also got a new IP address. Like I shown you, it's 0.4 now, but there's no 0.4 here. So it won't be able to connect with the front end. Clear? Now where does service come in? What service actually does is that it creates a platform. It creates a platform. This is 1, this is 2, and this is number 3. Service basically creates platform that connect to the main service. So this is the service, this is the service object, and it is creating 3 common platforms. 3 common platforms. Now you just place the pods on top of the platforms. Okay, and if this dies, a new one comes, you don't bother about the pod. You just need to know in which platform it is, right? So let's say that this will be commons. This is the common node, so all of the platforms will get the common port number. Let's say it is 80, so this will also be 80, this will also be 80. Clear? Now on this platform, if the pod dies, another new pod comes in, okay, of 0.4. The IP address changed, this changed, but did this number change? No. So regardless of the change in the IP address, the platform port or the platform number will always be constant. So if the backend basically connects to this service, it will automatically redirect to one of these three pods automatically. It doesn't have to be bothered that whether this is eligible or not, whether it is the destination where I want to go or not. Clear? It will only have to connect with the service, and the service will lead it to the three platforms, and on the three platforms you have your designated replicas. Clear? So why do we need service? Well, here I have shown you basically service creates a fixed endpoint. A fixed endpoint. Regardless the change, whether it is 4, 5, 6, 7, anything, it can change. It can be new, but this number here, this number here, this number here are connected in the common node, which is always constant. So regardless you change this, it will always be on 80, 80 and 80, and anyone from outside only needs to be connected with the service to get connected with the platforms, which will connect them with the pods. Clear? Okay. So the first thing, that why do we need service, is that it offers us, or it has a what say characteristic of assigning fixed stable endpoints, so we don't have to bother that whether our IP address is changed or not. Clear? Okay. The second thing is that it exposes the group of pods. What do I mean by that? Like I said previously, before you had the replica set, if you were to connect with the pod, you had to directly connect with their IP addresses, right? So this backend pod were to connect to any of the pods here, it directly has to see that is it in its list. Okay, then go to their respective IP address and connect. Okay, but now since there's no individual connection, what the backend will do is that it will connect with the service, not with the pod IP address. It will connect with the service. Okay, this is the common point of exposure. These three pods are connected with this common node, and anyone who wants to interact with the pods just has to ask the service. It is a common gateway. So like this, service exposes the group of ports. It creates a common exposing port. Clear? So this is the reason why we need Kubernetes service. Okay? Okay, fine. So I think I'm clear on what is Kubernetes service and why do we need that. Okay? So from whatever I have told you so far, you can understand one thing, is that service is, in a vague term, connection. right? Now connection between what? It can be, as I have shown you, connection between pod to pod. It can be connection between node to node, or it can be connection between node to user. What do I mean by that? Connection between pod to pod is that suppose you have 3 pods. Service acts as a medium to connect the 3 pods together so that they can talk between them. The interactive communication between the pods. Clear? Okay. What do I mean by node to node? Suppose you have 2 nodes here. 2 nodes, both have pods inside them, both have pods inside them. The connection between these two actual node 1 and node 2, is the node to node connection. Clear? We can achieve that also by services. And what do I mean by this? Node to user. Suppose you are an user, an outsider, and this is your node 1. And through a service, you will be able to reach inside the uh, node pods. Okay, so it also acts as a medium of exposure to the outside world. Clear? You are, you are an user. This is a pod. This is a node 1, and inside that you have pods. You need to access this pod right here. So what will you do? Suppose there is a service, you will just pick the service, call the service that I want to use this one, and the service will redirect you inside the node pod. The pod is inside this node. Clear? So these are the 3 types of connections, okay, that can happen. And based on this, we can also have types of services. Okay, when we need pod to pod connection, the communication between the pods, we create something called ClusterIP. When we need node to node connection or node to user connection, we have 2 options. One is NodePort, the other is LoadBalancer. LoadBalancer. These are the 3 types of services. 3 types of services. Clear? Okay, fine. Now, before we get onto the hands-on and create this ClusterIP, NodePort, load balancer, we need to understand that what actually do I mean by that. So let's get to the types of services. Okay. So already I have described about the ClusterIP. Still, let me again elaborate. Suppose you have a pod 1, and you have 3 copies of them, pod 2 and pod 3. Okay, now what the service does is that it is a common point. Suppose this is the service. What will it do? It will connect the 3 pods, and the pods will be able to connect with each of them separately. So this pod can connect with this one and this one, as well as this pod can connect with this one and this one, and also the same thing goes for the third one. It can connect with this and this through a service, and the service that can do this is called ClusterIP. Clear? Fine. Now in ClusterIP, it is specifically pod to pod connection. No external request can come in. No external request. It is internal. It is completely internal. And how that connection happens, as I have shown you, these 3 pods are on a platform, right? And these platforms have their IP addresses. Sorry, these have their port number. This will be 80, this will also be 80, and this will also be 80. I have shown you, right? And the service itself will have another port number. Let's say it is 100. Okay, so if we want to see the service, we just call port number 100. And if I want to go to this port, the service, we access the service in port number 100, and it redirects us in any of the uh, port. And now what is the name of these ports? This is really important. The port that is connected directly to the service, that if we just enter this port number, we will access the service, is called just port. And the platform on which the pods are standing, okay, these three, this one, and this one, these are called target ports. Target ports. So basically, when we press 100, it will go to service, and the service will redirect us to the target port. Clear? Anyone? Okay, and I have also already mentioned quite a few times that regardless of the changing of the port, our connection will still remain same. Why? Because it is on a platform, these three platforms, and these will have a constant connection point. Clear? So this was cluster IP. Let's move on to the next one, which is NodePort. NodePort. So the name already suggests kind of that what is it? Okay, what is it? It is basically exposing a port to the node. So what do I mean by that? We'll take the exact example, but let me just illustrate a bit nicely. Suppose this huge box is our node. This is our node. Clear? And inside this huge box we have our what? Service. Let's name it service. And we also have our three pods inside the node. So let's have three replicas, 1, 2, and 3. Fine. So what do we mean by NodePort? First of all, again go to the cluster IP. What did the cluster IP do? Basically it connected these three things, 1, 2, and 3. These three pods are connected with the service. By this point it is cluster IP. But what is exceptional in NodePort is that the service extends one hand outside of the node, creating an external port, this one. And this is called the NodePort. This is why it is called NodePort type. Okay? Why? Because it just raises one hand outside in the port. So anyone from the outside, let's say an user, just connects with the NodePort. The NodePort redirects in the service, and service passes the request to any of the available ports. Clear? Okay, fine. So another thing is that we all know that these will be in platforms, and the platforms will have some ID. Let's say what? Let's say that it is 80. So this will also be 80, this will also be 80. Again, the platform number or the target port that you see here, the platform ID, will always be what? Constant. These will never change. It will stay as it is. Clear? So these are the target ports, And I have also mentioned that the service itself will have a port number. Here you can see 100, right? So again, we can access our service by port number 100. And the main difference here, main difference of cluster IP node port is this line, that it extends a hand outside the node. It creates an external port of the node. So let's say this is the node port, not let's say, and there's a limitation 30,000 to, I forgot the range, I guess 32,000, the available port numbers range. Clear? Okay. So this is the node port. Basically, you enter the node port anything between this range. This goes to the service of the port number 100. This passes any of the available platforms which are on a common port target port number, that is 80, which then redirects to any of the port available port. Clear? And again, this number that you see, these three numbers are what? Target ports, target port. This number that you see here is our just port, and this number here ranging from 30,000 to any of the I forgot the range, it might be 32,000. This is called node port. It will come in handy when we actually do it in hands on. Okay, so this was the structure of node port. Again, in short, it is basically a cluster port, but it extends a port outside the node. This port is basically a port of the node. Okay, you access the node port and go inside the services. Clear? Okay, fine. Now, the third one, that is the load balancer. The load balancer is introduced because of the failure of the troubles of the node port that comes along. Why the trouble? Let me tell you. Just imagine that this service is a common platform of these three pods. So anyone from NodePort, by accessing NodePort, gets an access to these three pods. So this is a security issue. First of all, it is a security issue because anyone having the port number can easily access our three internal ports. Number one. Number two is that it doesn't support any efficient, intelligent load balancing. Now, if this is almost filled up to 90% and these are left, it won't get that I have to distribute the weight in these two pots. Okay, it doesn't have that knowledge. Clear? So, because of these two faults, one is security and the two is load balancing, we need a third kind of service which is called what? I can write it here. Let me just erase this one. Which is called load balancer. Load balancer. It is almost the same. Just the change is that instead of node port, what we use? We use a load balancer. A load balancer. And now you might be wondering, what is a load balancer? Well, this is not anything of Kubernetes itself. It is an outsider. It is an outsider. And it has to come from any of the cloud providers like AWS, GCP, or Azure. So if you are using any of the Kubernetes services of the cloud providers, AWS, GCP, or Azure, they have something called load balancer. Okay, when you use any of their tools as a load balancer externally and then introduce it to your service, it is called load balancer service. Mind it, load balancers are not internal or part of Kubernetes itself, but it is a service of the cloud providers which we can integrate. Clear? And when we use load balancer, it is really an intelligent service which knows how to load balance that NodePort couldn't, and since it is of a reliable company, AWS, GCP and Azure, it also maintains a strict security guidelines or protocols. Okay, so we don't need to worry about the security and also node balancing that much. It is easier, and this is the load balancer. So guys, by this time, what have I discussed? Let me give you a really quick recap. Then we will move on to the hands-on part. Okay. So by this time, we have discussed about services. What is service? Basically a connection. It can be connection of pod to pod, it can be node to node, or it can be node to user. Okay. And I have discussed why do we need service? Why? Because it offers a fixed endpoint, first of all, and secondly, what? Secondly, the exposure. It gives a common exposure to the group of pods. Thirdly, I've discussed types of services. The first one was ClusterIP. ClusterIP is basically the connection between pod to pod. The second one was NodePort, which is basically ClusterIP itself but extending one arm outside so that any external user can make requests inside your pods which are inside the node. This way you can also it can also act as a node to client or user connection or node to node connection. Clear? Okay. And the third one was load balancer. It is exactly like NodePort, but we use an external load balancer of any of the cloud providers and attach it with the service, and it basically becomes a load balancer. Clear? Okay. Another important topic remains, but still another a a brainstorming thing is that you can imagine this. Hope this is a circle. You can imagine that. Okay, let me just draw it myself. So you can imagine that this is ClusterIP inside this circle, and this is the NodePort outside the circle having ClusterIP inside. You can imagine like this. Okay, and on the very outside you have the load balancer, because the NodePort is also kind of a load balancer. Think this one and do some brainstorming, guys. What do I mean by this? Okay, the ClusterIP is basically the connection between pod to pod. If it only has one arm attached outside, it is NodePort, and the attached arm, if it has a load balancer attached, it is a load balancer service type. So now, before we get to the hands-on part, only one thing remaining, that is, how do we know which pods to connect? Right, like here you have seen that I am talking about pods, 3 pods here, as you can see, 3 pods, this one, this one, this one, and in above I've also discussed this. But how do I know that which pods to connect? How do my service knows that? And the answer is through label and selectors. Again, because we use the same thing for deployments and replica sets, and I have shown you that how deployment and replica set use the same thing, label and selector, to select the pods they need to work with. I'm again just simply showing you that suppose this is a pod, this is a pod, and this is a pod. And we all know in YAML file in the metadata we can have something called label and label anything we like. Let's say we are labeling this pod app, app, and app. This will have this will also have app valued a, but this one having a value of b. Now if you want to select app a, okay, we just put it in the selector, see the selector parameter, and just place the name. And then what will it do? It will pick the pods having app with a. Okay, it won't pick this one cause it is app valued b. Okay, now if I have it b, then it will pick all the pods inside your cluster having label app equals to b. So this was about the labels and selectors. So similar to the deployment and replica set, you can use this label and selector to select your pods for services as well. Clear? Now we get to the hands-on part. How do we actually create services? So let me show you the documentation. Okay, this is the documentation of the official Kubernetes, and we have services here. Let me just go through a bit. Expose an application running in your cluster. Okay, we have discussed this one. We also have discussed this part. You can have a read that each pod gets its own IP address for a deployment, blah blah blah. It is basically saying that for a given deployment in your cluster, the set of pods running in one moment in time could be different from the set of pods running that application a moment later. That thing I have mentioned, that the IP addresses in a pod can change. This is a problem. Okay, and basically service solves this problem. Okay, if we just get to what else are there? Okay, here you also can see the set of pods targeted by service is usually determined by selector in your YAML file. Okay, more, there's some extra stuff, but as it is a beginner type of session, I am not going there. Okay, what else do we have? Yeah, so let us make a service. Okay, let's get to that. But before we can make a service, what do we need? We need pods actually, right? If we don't have pods, then how can we make the connection between pods? So making the pod itself is a must. Okay, so let's create pod. Let us go to pods Kubernetes. Okay, and copy from there, or rather let us create deployment instead, because we all know that through deployment we can create replica set and also the replicas of a pod, right? So let's copy this one and let's go to our killer coda. I have already spoken about what is killer coda and stuff. That killer coda is basically an independent isolated environment, and what killer coda does is that it basically gives you a playground of Kubernetes cluster, okay, for 1 hour. So for our use we are going to be using this one because I don't want my working cluster or nodes and stuffs get interacted here. Okay, okay, fine. So what first we are gonna do is that we are gonna create a deployment. So let's create, first of all, vim, let's say deploy dot yaml, sorry, it is vim, yes, and let's just paste whatever we have copied. This clear? This is the YAML file for the deployment we are about to create. So let's go colon wq here. Okay, if you ls, you will find the deployment.yaml. Now let's create kubectl or kubectl create -f deploy dot yaml, and our deployment is created. Let's clear it up and let's see that what do we have in our system. Kube get all. Now as you can see that here is our deployment, here is the replica set inside, and these are the pods inside the replica set. Here you can see the service that is pre-created inside the killer code. Okay, we are not gonna be using this one. Okay, mind this. Okay, it is in ClusterIP. It is a ClusterIP on this node. Okay, we are gonna be naming our service, so don't worry. Now let's create the service one. Before that, let me go to the actual documentation YAML file, which will be easy to relate. Where is that? Yes, this one. Let's pick this one. This is the service YAML file. Okay, I've copied it. Now, sorry. Now let's create a service. Vim service dot YAML and just paste it. Okay, this is very simple YAML file. Okay, but one thing is missing. We have created the pods, but we are not actually selecting the pods here. As you can see, there's no label and selectors. So will our pods that we have inside our cluster get selected in the service? No, it won't get selected. Okay, this is why we need the label also. Okay, so let's pick the label. Let's again go to the documentation and let's see, where is it? Yeah, this one. Let's copy it. See this selector, this is basically selecting the labels of whatever pods that you have already present. Okay, clear, fine. So we have already copied this one, but we need to know the labels. Okay, we don't have the exact label. Let's cat deploy, or let's see kubectl describe what deployment dot apps. So in the description you will find everything, every labels, etc. So let's see the pod label that we have for our purpose. So here you can see the name of the deployment, the namespace, the creation timestamp, when did you create it, the label. It is the label that we need. So let's copy this one. App is equals to engine X. Clear? Okay, this is the label. The selector for the deployment, as you can see, it is also the same. So it is app equals engine X. Okay, let's clear the view and wait. Let's again create the Vim services service dot YAML and let us paste. Oh, sorry again. We need the previous one. Okay, this one. We need this service YAML. Okay, now paste it. Now the thing is, in selector here it has app.kubernetes.io equals to my app, but what the pods inside our system doesn't have this selector. So basically what I'm trying to say is that our selectors, sorry, our pods inside, we have 3 pods, right? I've shown you. This has label called app nginx. App nginx. The same thing goes for this one. Okay, but in selector, what we are saying that we have something called app dot kubernetes equals to my app. So the selector here and the actual label of the pods doesn't match, so the service won't be able to pick them. So what do we need to do? We need to cross this one and make the selector accurate. So what we need to make is that we need to have the label as app equals nginx. Only then this selector here will match the labels of the pods and the pods will get connected. Clear? Okay, so let's do that. So where are we? Here. Let's go to the top, and we only need the app, which is nginx, and let's name our service. It is my service. Okay, it's fine, it's my service, no problem. Okay, so guys, another thing I've forgot to mention is that you have to do the protocol. Okay, this is the protocol. You have to mention the protocol name. Okay, and there are multiple protocols. If you want to see this, you can just go to the documentation, and it is here somewhere. Let me see if I can find it for you. It is here. Yes, the default protocol for service is TCP. You can also use any other supported protocol. If you just click on this link, and you will be directed to that. But for my use, for this session, I'm just leave it the way it is. That is TCP. Okay. And what else do we have? We have port number and target port. Let me again remind you what is port number and target port. The port is basically this one, where service is located. If you access this port, it will redirect you to the service. And the target port is basically where the pods are situated. Okay, these are the target ports. Clear? So the port and target port basically connect with each other, these two. Okay, so we need port and target port number. So here we have port 80 and target port 937. So these are the basic 3 arguments you need in your spec of service. Oh, I forgot to mention this. The API version is v1 and the kind is service. Disclaimer is that the naming, the case sensitivity has to be exactly what is present here. You can't just do anything else, or else you won't be having the Kubernetes object made. Clear? The metadata is your choice, the details about the service itself, and the spec is the main thing. In spec, you need to have a selector. It's a must. Otherwise, you won't be able to pick which ports to connect. The port is another one which is really important, where you have to mention the protocol, which protocol will be used, the port where the service will be situated, and the target ports where the actual ports will get connected to. The pod and target port basically connect with each other and create service. Okay, now another argument that comes in here is something called type. Okay, it is something called type. It is another argument of the spec. Okay, here you can have cluster IP. Okay, I guess it is IP, or you can have what, node port, or you can have load balancer. When you have load balancer, there are further arguments I'm going to be showing you in the documents. But if you don't mention anything, any type, it will automatically create a cluster IP. Okay, if you want to create a node port, you just need to mention a node port here. Node, I guess it is capital port. Okay, and mention a port. And we have discussed that it has to be between 30,000 and something. I'm going to be showing you in the documentation. Let's say it is 30,000. Okay, and you're done. If you mention the node port, it will pick up the node port, and if you don't mention the node port, it will randomly give you a node port between the range. And yes, you have to mention the type as well. The type would be then node port. Clear? So we just need to change this part, this part. It can be ClusterIP, it can be NodePort, or it can be load balancer. If you don't mention any type, it will pick as ClusterIP by default. If you want to create a NodePort, you have to mention this NodePort. If you don't, it will pick a random number from its range, and you also have to mention NodePort in the type. And if you want load balancer, you don't need NodePort. Rather, you will be having load balancer here and some other arguments down the line. Okay, fine. But for our use today, we are just going to be showing you the cluster IP. For that, we don't need any type, and we also don't need any node port, because we are not exposing our service to any external request. Clear? So this was all about the YAML file of the service. Let's save it and let's create kubectl create -h and it is service, right? Service.yaml, and boom, service, that is my service, is created. Now if you see kubectl get all, you will see that I have two service now. First one was present, early one, but now I have my service, and as you can see, it is a cluster IP, and it doesn't have any external port. It doesn't have any external port. Clear, guys? And as you can see, the port number is 80 and the protocol is TCP. Clear? Okay, so this was the cluster IP, and I've labeled and selected these three ports for my cluster IP. Clear? I think I'm all clear on this one. Okay, for the node port and load balancer, I have given you instructions, and I'm going to show you in the documentation. Okay, okay, fine. So let's go to the documentation to finish off our session. Let's read it from the very first. I'm just gonna be mentioning you, and by far I have mentioned you only the basics. Okay, I'm here also gonna be showing you the basics. Expose an application running in your cluster. I have shown you here in this part. If you go a little bit down, you'll find why do we need services. I have explained that the IP numbers changed, but services provide us with a solid fixed endpoint. Clear? Okay. Services in Kubernetes. Here you can see that the set of pods targeted are determined by selector. Okay, fine. These are some advanced stuff. You see the selector parameter here. We have changed this one, right? We have changed this one so that our pods get attached. I can show you that whether our pod actually got attached or not by kubectl describe. What was the service? My service, I guess, no? Yeah, my service, my, yeah. Let's see. You see the name is my service. The namespace is default namespace. If you know about namespaces, here the labels, it doesn't itself has any labels annotation, but it has selector app.nginx. The type is cluster IP, and other information related to IP and ports. We have selected ports and 3 endpoints. Okay, the target ports, remember? Yeah, these are the IP, and the target port is 937, but these are the IP addresses currently present in the ports. This can change, but target port can't change. Clear? I have mentioned multiple times. Now you have session affinity and etc. Okay, clear, guys? Okay, so this was the cluster IP, and what else do we have? You can have a small recap of the documentation, which is not that hard. Okay, you can just put in 30 minutes and you will be really good. Okay, I have explained you this. Labels. Okay, fine, you just put the appropriate label and selectors. Again, what else? If you go down the line, you will see the types. Let me show you, where is it? You can have multiple ports in services. Basically what is meaning is that through NodePort, what I have shown you, that suppose this is a node, this is a node. Now this is one node port, say node port 1 for this service 1. But if you have another service inside the node, you can also have node 2 or as many node ports as you like, but this one will only lead to this and this one will only lead to this. You can do that also. You don't need anything, just you need this one is for the first part, okay, and this one is for the second part. You just need to change in the YAML configuration. Clear? Okay, this is the service type that we are talking about. You can see cluster IP, NodePort and load balancer. Two are extra. uh, I guess one is headless and one is external name, but these are not basics. Okay, so the type is cluster IP, as you can see, and this is the default service type. If you don't mention, it will pick this one. Okay, it is kind of if you don't mention it, mention the port, then it becomes basically headless. Okay, okay, fine. If you pick cluster IP equals to none, then it becomes headless service. Clear? Okay. Then we have NodePort. In NodePort, we have an example here. Type needs to be mentioned. Type is NodePort, and a NodePort itself needs to be mentioned. Another thing, there's a range. Let me see where's the range. Yes, this is the range. 30,000 to 32,767. The node port must be within this range. If you put anything outside, it won't create a node port for you. Clear? Okay. What else do we have? We have what? Load balancer. Yes, type would be load balancer. And if you put on load balancer, then you can also add some other configurations and parameters as well. Okay, so this is when you use cloud, basically. Clear? Load balancer is kind of an extra what say, advanced stuff, and most likely we will be using load balancer and cluster IP, because I have told you that NodePort, it has its disadvantages, right? The security issue and the load balancing. So this was the basics. Okay guys, the basic of services. Okay, so to close the day, I'm gonna show you a NodePort. Okay, also, although I have shown you what is NodePort and not, still let me show you a NodePort. We already have our YAML file present here, as you can see. Let me create this, copy, and let's create vim called service2.yaml and just paste it. Yes, as you can see, we have port 80, target port 80, the node port within the range. We just need to change the selector, so let's change the selector part. Where is the cursor? Yes, what was our selector? The label was what? App equals nginx, and let's give the name my service 2. Clear? Let's save it and kubectl create -f service 2 and boom, we have created my service 2. And if you do kubectl get all, now you will be seeing that we have two services present here, but the main thing is that this one has a type of node port, not cluster IP. Clear? clear. If you just also see, if you want to see the description, kubectl describe service sorry, my service 2, right? My service 2. Let's go inside. Here you can see the name is my service 2, the namespace is default, and the selector is app and Nginx, the type is NodePort, and all about the IPs and ports. Target port is 80, the endpoints are present also, the NodePort as well, and we are done. So guys, this was all about services. I have discussed what and why. I have discussed how that the service select the pods inside the cluster, and also I have described about the types. Okay, what, why, the types, and how, with hands-on. And this was the basics of services of Kubernetes K8, and that's all for today. Thank you.